People always seek improvement to make processes better, faster, easier, and cheaper through innovation. Seeking evolution is in our humankind DNA for survival. New things usually interest us more, even when at first we are not big fans of it. This has become evident in one of the oldest and largest industries in the world, the construction industry, playing a key role in the development and economic growth of all industrialized nations. Thus, construction innovations are an inherent aspect of the industry. What if there existed an alternative to sand and cement blocks stronger than concrete and much more energy efficient? A material which is made up of 98% air and easily recyclable. Expanded polystyrene technology. For several years, expanded polystyrene has been utilized as a material of choice in several food packaging applications, cushioning transport packaging material for shock-sensitive goods, and also cost-effective and energy-efficient insulation in construction applications.
We've been used to the conventional materials, that is the use of your normal granite, sand, stone dust, and then the reinforcement bar, which we call iron. Now, as the technology improves, there was a need to introduce other materials that can actually reduce the overall weight on your structure. Every engineer will look up to that. And then also still reducing the cost of building production. That's where the expanded polystyrene comes in.
As it simply sounds now, expanded polystyrene, it means there's an expansion. Polystyrene, first of all, is a petrochemical material. It's a combination of benzyl and ethanol. This material comes in small beads. When it comes in contact with steam, it expands. And that's why it's called expanded polystyrene. The reason why we expand polystyrene is because when we expand it, it gives us 40% of its original size. When this thing expands up to this volume, you can now see that the material is 98% air.
Shelter has been an age-long with humanity, and people begin to improve on it on daily basis.
The expanded polystyrene is an innovative building material that lends to the design and structural integrity of building projects.
It's an innovation by one person. The other people bought into it and improved on it. First, we started with clay. That is when our grandfathers were using clay to mold a house. From there, they graduated into what we call breeze block or concrete block, as it is called now. Now, as they were building on it, idea is coming to human's head. People are now moving from that particular in situ casting, which is a solid, massive concreting in a structure, and now they are now making it light. With this, polystyrene is light and it's economical.
If only Nigeria is maximizing its potentials in terms of the refineries that we have, it's supposed to be like a waste product in the refining in our refineries, just like the way you have sawdust in the sawmill. So, and this is occupying 70% of your slab system. So you all, with the remaining 30% is what the conventional material that you've been using in the past. Imagine saving 70% of such material from your slab system.
You need a material that will not rot, a material that does not decay, a material that withstands all weather.
If you make use of expanded polystyrene as your wall system, the problem of the dampness in Abuja that you see in every house, where you see literally water at the lower part of buildings, is completely eliminated when you make use of expanded polystyrene panels. Because polystyrene does not absorb water, the water absorption rate in polystyrene is near zero. So you cannot see all those water stains on polystyrene wall.
The most economic benefit of EPS is its lightweight, meaning that it does not exert heavy pressure on the foundation that may cause a collapse.
You know, you can see that in our world right now, most especially in Nigeria we belong, we have been hearing about shaft failures, building collapsing. It's because of the excessive weight on it. Now, you know, structures start from the foundation. The essence of foundation is to have a stable footing for the building, which is on the foot or on the column base itself, and the columns, then the beams and the floor, on and on from floor to floor. But with this particular polystyrene walls, it is light, very, very light, and it's safe, and it's cheaper.
Every engineer would do everything possible to reduce the overall weight on the structure. And this material really comes in handy. And not just that, you are also saving cost. And it's actually faster, because when you are doing the conventional material, the carpenter has to do form work, the iron bender will have to come and put his reinforcement, then the people that are casting, they will still come and do. But if you are making use of expanded polystyrene, it's a job that can actually be done in one day, irrespective of the size of the project. All they need to do is to just mount and hang the cornice around the building, and then you are done. You have actually succeeded in reducing the weight on this structure, because by introducing those, you have actually reduced the volume of concrete that will have come into this structure. All those places that the polystyrene is occupying, ordinarily your conventional is concrete that will be occupying those spaces. And of course, you know how weighty concrete can be. You are not feeling any form of vibration. That's one of the things you can actually do to check. If you go at any point, if you are feeling vibration, a sound of boom, boom, then is a negative, it's not supposed to be.
APS is an inert material that does not rot and provides no nutritional benefits to vermin, therefore does not attract pests such as rats or termites. Its strength, durability and lightweight nature makes it a versatile and popular building product.
We have what we call precast and in-situ. In-situ is a situation whereby you pour the concrete on the formwork on the structure. Whereby precast is you cast it on the ground, then you now install it, or what you have on the ground according to the architectural design and the structural design. But you see, people begin to bring an idea into building.
If you are thinking of a very fast way to deliver a project, it's very efficient in timely project delivery. If you also want good thermal and acoustic value as a material, think of polystyrene.
You can actually make use of the material for your wall system. That is what you're seeing. That first one that you saw there, that you are seeing there, is when you just install the panels, and those irons that you are seeing holding the panel into positions, they must have been put in your foundation slab. So those irons must have been dropped along the line of the walls, and then the installers, and it's not a difficult thing anyway, you can have your iron benders install it. Anybody with technical knowledge can actually install this panel, so it's not a rocket science. You install the panels along the line of your walls, following your architectural drawing, and then after that stage, it is this next stage. This next stage is what you call shotcreting. Shotcreting just involves the process of spraying your panel with spraying gun. If you don't have spraying gun, there are other manual methods that you can actually use, but spraying gun just quicks the process. It serves as a form of interface between your naked polystyrene, that is that galvanized and meshed panels, and your plastering. That's the plaster process. So after you must have done your shotcreting, then you can now have your wall. You can see that there's no difference between that and any wall you see.
Today, the construction sector faces the dawning of another new age, and it has everything to do with environmental protection and population growth.
Nothing is wasted. Like all the soft core that you are seeing now, by the time we are done with site, we are still taking them back to factory.
You want to take a block out, or you want to take concrete out of a building, you have to chisel, and that is in a way affecting the building itself. But polystyrene, the little concrete that you are going to add to the surface and the iron that you are going to add to it can be easily removed.
You are doing residential houses, and then you are doing solid slab. You are wasting money. You are doing like 200 units of houses, and you are doing solid slab. You could have actually saved like 1.5 million on 100 houses. That's more than 100 million. By the time I meet you, if you tell me that you are using 3 million to do your slab, I'll tell you I can give you for 2 million. And then you want to listen to me, and I will do it. I will have saved you that 1 million. I will just collect the percentage of the 1 million I'm saving for you. That's mine.
Applications include insulated panel systems for walls, roofs and floors, as well as facades for both domestic and commercial buildings. EPS is widely used in many everyday building and construction situations where its lightweight, strength and thermal insulation characteristics provide cost-effective high-performance solutions.
When it comes to engineering, we talk about accountability. Give the best, but with minimum cost. So by the time you check the two, which one is cheaper? You and I agree that it's cheaper to go for polystyrene.
It's even stronger than your block wall. You can put me to a test, take it anywhere. Put me on camera. It's stronger than your block. Yes. This polystyrene that you are seeing, if you look at this, is already meshed. This is a galvanized wire meshed panel. You can see. By the time you shortcrete this and you have this, in fact, by the time you touch this is already almost stronger than your block wall.
Various studies have shown that a 2700 mm single panel of EPS can withstand a load of 1530 kN when subjected to axial load, which is sufficient to sustain double the dead and live load of a residential building when compared to conventional concrete block. Its stability does not deteriorate and absorbs moisture under usage, as this is a major challenge to structure in the cold climate area.
If you can actually hit the two, and then which one comes down first will give you an idea of which one is stronger, and then that can actually be traced to the fact that it is meshed. By the time you carry out a compensation test on this and that of Sandriver, you discover that the values you obtain for this is higher.
Construction companies need to start adding innovation in their strategic plans as soon as possible. The use of new technology will not only boost productivity and increase profitability, but also create a safer work environment.
The first upstairs that is known unto man in Nigeria was clay and planks, which was built in Badagry many years ago.
My father's house, or my grandfather's house, so to say now, the slab there, the decking there is wood. I don't know if you come from that part of the country. It's wooden. What that simply tells you is that even wood can actually do the work of a decking. It's wooden, purely wood. Are we going with conventional method by making use of reinforcement and concrete all over the place, when you can actually do this and then save cost, save time, and then even reduce the overall weight on your structure?